Our next exercise, exercise A07, is going to lead us to add yet another feature, and this is going to be the last feature for that little game, which is we want now to have a maximum number of possible guesses, possible trials. So before even to ask the secret number to player 1, we are going to ask also for a max trial number. And we're going to make sure that every time we have player 2 make a guess, we are going to display for player 2 you have n guesses left, and we are going to exit our loop once nb trials, the number of trials made by player 2, reaches max trials. And we're going to display a message that is, you lost the game by exceeding your amount of trials, something like that. So let's go back to the code once again. This is what we have so far, so let's review. We are going to have to ask player 1 here for more information. So I'll drag an input box here and I double click on it. We need to ask player 1 about how many trials are allowed in the game. Okay, what is the maximal amount of trials allowed? And we store this in the variable max trials. So once we know how many trials we allow maximum, then we need to go back to our code here. And what is happening? We can start by reading a guess. And then we are like checking if guess is secret or guess equal -1 to decide if we get out of the loop. Well, there is something new now. If the player has been guessing one too many times, we need also to exit this loop. So this condition is going to get even more complicated because we are going to say you exit the loop when the secret number was found, or when guess was -1, meaning that the player doesn't want to play anymore, or when NB trials is actually equal to max trials. Okay, so the first reflex to solve this problem is to go here in this loop condition and add another OR statement. When NB trials is equal to max trials, I need to get out of this loop. Okay, let's stop a minute here and think to what is going to happen. Okay, when I reach this part of the code, okay, let's say I just entered my first guess. Okay, the secret number is 42, my guess is 23. What's going to happen? It is not equal to secret. Guess is not equal to -1. I didn't give up. I tried to make a correct guess. NB trials right now, if it is my first guess, NB trials is equal to 0. Let's say that my max trial is 1. I allow my player only one single guess. Well, I just made that guess. However, NB trials is 0 and max trial is 1. So this is not going to work. I'm off by 1 once again. Okay, why? Because I chose to start NB trials to 0. So I could go back here and modify NB trials initialization. However, everything else is working in my code based on NB trials equals 0. To start off with. So if I modify this, I have to go back and recheck all of my logic for all the conditions, for the placement of the incrementation of NB trials, etc. Similarly, I could say that after each guess, I just move this incrementation statement here and put it here. And that would work. Yes, that would work for me detecting if NB trials is equal to max trials, but I would count a -1 guess as being yet another trial, and this would like mess up another part of my program logic. So you need to, when you add feature, you need to keep in mind the big picture of your program, okay? So I don't want to go ahead and destroy everything that is working so far. However, I want to make sure that here, knowing that I start NB trials at 0, okay, I want to make sure that my condition here is not comparing NB trials to max trials, but comparing NB trials to max trials -1. Okay, which means if I have only one maximum number of trials available, when I enter my guess here, NB trial is 0 for now, well, I'm going to compare 0 to the maximum -1, which is 0, and I'm going to figure out that yes, I had only one guess and I messed it up. So I need to get out of the loop right now. I'm allowed only one guess. So that's the first part of the job. Modifying this condition and try not to break everything that is currently working in my program. Now, what happened when I get out of the loop? There were two reasons for which I could get out of my loop so far. Now there are three. The new one being I exhausted my maximum number of trials. So let's revisit this conditional. If guess equals secret, yes, I just won. Okay. If I had only one trial available, okay, so NB trial is equal to 0, max trials is equal to 1. When I reached this conditional, if I guessed wrong, I will exit because NB trials is equal to max trial minus 1. If I guessed right, however, two parts of this conditional are going to be true. First, guess is going to be equal to secret. I just guessed right on my first shot. And NB trial will be equal to max trial minus 1 because I had only one shot and I just used it. So when I get out of the loop, I need to first test that I won. Guess equals secret. Now, if I didn't won, I'm going to ask myself, well, what happened? Did I lose because I gave up? Or did I lose because actually I reached my maximum number of trials? Well, this is relatively easy to detect. Okay, I can go here, edit the condition, and decide that if NB trials is equal to max trials minus 1, if I am in this situation, that means I used all of my trials. So this is going to help me shape an appropriate error message. Okay, if this is the case, then I can here add an output statement that says, double click on it, this output statement will say, you used all your guesses. And between parentheses, I'm going to remind the player of how many guesses he or she had. Max trials. See here how I make a string that has a number between parentheses by just concatenating several strings. And I choose output expression, and I'm done. If not, well, then I want to move this here. Okay, I didn't use my maximum amount of trials. Okay, I just pretty much lost, I gave up pretty much after NB trials. So I can even change this message. How can we formulate here? You quit the game after NB trials. And there we go. So we have now the code capable to handle this new feature of the game. And I will leave it as an exercise for you to actually test thoroughly this code so that you make sure that it works in various scenarios. The same way that we used test harnesses by writing down on paper the value we used to test our program, you need, when you have to test an interactive game like that, to develop test harnesses as well. Okay, how are your test harness going to work? Well, let me give you like a good idea of how you are going to design this. The way that you are going to design this, you are going to want to test all the possible outcome of the program. Okay, what are the outcome you want to test? Well, the ints. Are the ints working? I want to test that my program is capable to give me a hint that my value is too big. I want to test it's capable to give me a hint that my guess is too small. Okay, I want to be able to test that my program detects when I just won. I want to be able to detect that this program works when I use -1. Okay, when I give up, use a give up option. I want to be able to test that my program detects that I win within max trials. Okay, and I want my program to be able to detect that I lose by exiting max trials. Okay, so this gives you a picture, and by the way, the -1, you can also consider it as being a way to lose, of course. So you need to get on a piece of paper these ideas first, okay? What do I want to test? What are all the possible feature, outcomes, situation that my program can handle? And then, once you are there, you can start writing down a scenario. How are you going to test that your hints are too big and too small? How are you going to test that this feature is there? Well, you are going to start with a secret number of 42, and then you are going to use a guess of 90. That will take care of that. Then you are going to use a guess of 1. That will take care of that. Then you are going to use a guess of 42. That will take care of detecting that you win within max trial. Oh, wait a minute. What about max trial? Well, for the above scenario to work, you need a max trial that is at least greater or equal to 3. I need to allow at least 3, okay? Interestingly enough, if I allow 3 for max trials, I'm going to take a first test here, a second, and then a third. I'm going to win on my third max trial. This is very interesting to test because you saw how my condition can be triggered by 3 different possibilities, okay? When I do this test, I trigger 2 possibilities at the same time. First, I exceeded my max number of trial. Second, I am also right. Guess is equal to secret. So I'm going to test this with max trial equal 3. Then I'm going to make another test with max trial equal, let's say, 9. Just to make sure that it's working in both cases. Then what? I'm going to try to test if I can lose by exceeding my max trial. So I'm going to keep this series of guesses, but I'm going to set max trial to 2. Just for the heck of it, I'm going to also set it to 1 to see what happens when I have only 1 trial possible. Okay? And then I'm going to test it with max trial equals 0. Does that really make sense? Well, not really. But it's by testing my program that I'm going to realize that having a max trial value of 0 doesn't make sense with my code, because my code is still going to ask you a first guess before to figure if it should exit. So what happened with this? Well, you have to reconsider. Maybe you need to change your code. Maybe you need to just make sure that the max trial can never be 0. So make a conditional statement that refuses the value of 0 for max trial, but ask for something at least bigger or equal to 1, etc., etc. But what is really interesting is that the process of defining your test harness helps you figure out things that are not so clear when you first read the programming assignment, okay? And then finally, to complete your test harness, you will have to test giving up at some point, okay? Giving up right when you reach the max trial, giving up before you reach the max trial, and stuff like that.